All right, so this is going on page 42. So we're going to be combining, now that we just went back over product, quotient, and other things, we're combining the chain rule with those things. So there could be a couple of things going on. Repeated use of the chain rule, or the chain rule with problems requiring product or chain rule. Okay, so we might have to like mix things up a little bit. All right, so it says sometimes we need to repeat the chain rule more than one time. For trig functions, the angle of the function never changes. Okay, remember that's the argument and it doesn't change. So the first thing we're going to do on A is rewrite it. Anytime you have a squared trig function, remember we want to rewrite it as something that looks like this. Sine of 3x squared. Okay, because that's what's happening, and then that's going to help us figure all that stuff out. Okay? Everybody good so far? All right, so our chain rule, f prime of x. We take the derivative of the outside and leave the inside alone, right? So we have the outside, which is the parentheses squared, and then this is the inside. Make sense? So the derivative of the outside, I bring down the 2, and I have this, and I subtract 1 here, so this is just to the first power. I leave the inside alone. Sine of 3x. Then I'm going to multiply that by the derivative of the inside. But look, the inside has an inside to it as well. It's called the nested chain rule. So I've taken the derivative of the outside, leave the inside alone. Now I move in. Now I'm going to take the derivative of the inside, leave this alone. What's the derivative of sine? Cosine. So this becomes cosine of 3x because I'm leaving that inside alone. You okay with that? Then I have to take the derivative of that inside. What's the derivative of 3x? 3. So when I put all that together, I get f prime of x is equal to, that 2 times 3 can be 6 sine of 3x times the cosine of 3x. Okay, because you got 2 inside, you got to keep going inside like a little nested doll or something. So here's what happened as we went inside. We took the derivative of the outside, left the inside alone. Then I have to take the derivative of this, leaving this part alone. And then I take the derivative of this and just keep going down the row. Okay? That makes sense? Good? All right. So let's look at B. I've got e to the cosine of the 2x power. So my g prime, knuckles keep biting. My g prime of x, I take the derivative of e to the x. What's e to the x? E to the x. So this just stays e to the cosine of 2x, right? Then I have to take the derivative of the cosine of 2x. I leave the 2x alone. What's the derivative of cosine? Negative sine. So it's going to be negative sine of 2x. You never change the argument inside of there. And then I have to take the derivative of the inside of that, which is 2. So that means that g prime of x, just to clean it up a little bit, not that you would have to, but it'd be 2, actually I'm going to make that negative 2 because I'm multiplying all that together. And then I'm going to put sine of 2x times e to the cosine of 2x. You don't have to put the e last, but just because it has that big exponent, it just kind of makes more sense to write it that way. It's fine if you have e to the cosine of 2x power times a sine. It's fine, the order there. Okay, what do you think of that? Okay with that? Maybe? All right, let's try this one. I'm going to rewrite this as x squared plus the tangent of 5x minus 1 to the 1/2 power. Do y'all agree with that much? I just rewrote it. That's all that I did. Okay, so g of x I have this bad feeling I'm not going to have enough room. G of x, G prime of x, I'm sorry, is equal to, so I'm going to take the derivative of the outside, the big old parentheses, just this part right here. Okay. So that means when I do that, this is going to give me 1/2 times x squared plus the tangent of 5x minus 1 to the negative 1/2 power. Okay? I just took the derivative of the outside part of that. We okay with that? Then I need to work inside. So I'm going to multiply. I have to take the derivative of this part right here. So this is going to be times, I'm just going to go to the next row to do the multiplication. Then this, I can just use this first term, I can just use the power rule on, right? What is the derivative of x squared? 2x, okay? So I'm going to multiply that times 2x, and then keep on going, plus, what's the derivative of tangent? Secant squared, good. So this is plus secant squared of 5x minus 1. Like that part doesn't change. Okay. So I took the derivative of this, right? Then times the inside of this. That's the derivative of the inside there. Then I need to take the derivative of that inside. What's the derivative of that? 5. So if I was to clean this up, g prime of x. All right. So this 1/2, so I have a 1 in the numerator, 2 in the denominator. I'm going to leave the 1 off right now because I'm not going to need it, right? This whole thing is to the negative 1/2 power. So in the denominator, I have x squared plus the tangent of 5x minus 1. Excuse my weird writing. So I've taken care of this. In the numerator, I have 5 times 2x plus secant squared of 5x minus 1. And I could distribute that 5 if I wanted to, but we'll just leave it like that for right now. That's fine. Can I cancel those 2's out? No, don't do anything weird like that. Okay, we okay? That ugly? It's ugly, but we just had to keep going inside. Inside. All right, let's do one of these, and then I want y'all to work on some. Here, am I going to need to use the product rule? Yes. I'm going to need to use the product rule. Am I also going to need the chain rule? Yes. So product rule, those are the two things that are being multiplied together, right? So f prime of x equals the derivative of the first, which is 2x, times the second, which is the sine of 4x, right? Plus the first, which is x squared, times the derivative of the second. What's the derivative of sine? Cosine. So this is going to be cosine of 4x, because that does not change. But since there's something other than x in there, I got to take the derivative of that, which is 4. Okay. Make sense? All right, so we're going to write two different versions of this, or actually a couple. So let me just clean this up a little bit. I'm going to get 2x times the sine of 4x plus 4x squared times the cosine of 4x. That's kind of the cleaner way to write it, right? You wouldn't have to, but that's just kind of fixing things a little bit. I could also write this as 2x times the sine of 4x plus 2x times the cosine of 4x. Now, without context, me doing that, just because I can. But again, if it was multiple choice, this might be what your answer choice looks like, even though that's what you got when you first started. Okay, because all I did was factor out a 2x there. Okay, factored out the GCF. Because if you multiply it back in, you get this back, right? So you just got to be able to manipulate them and see the differences there. Okay, I see some blank looks. So if I take this and I multiply it back in here, wouldn't I end up right back here? I just factored out a GCF is all I did. Okay. Again, just because I can, because that could be the form of the answer that we actually see. Not that you would have to do that necessarily, unless you're trying to match something up. Or if I had like the denominator was all over 2x or something, maybe that would help me to cancel it out, or I don't know, whatever. Okay, we good? All right, y'all try B. Okay, so this is the latest edition. Y'all don't even have yours out. Get this back out. This is the latest edition of Confessions of a Bad Teacher, okay? Because I totally messed up on this one. And I caught myself afterwards, and then I meant to fix it yesterday, and I didn't. So what we're going to do is we're going to just put a big X through this, okay? I'll tell you what I did wrong before we redo it. But then, so you know how you fold your paper up like this, and this, since there's nothing on the back, okay, if you don't, well, as long as you didn't put your signature on the back, you'll still have room. But we'll just write it right here. We'll just redo it, so we're not erasing anything. But let me show you what I did. Is in this step, and we'll, like I said, we'll redo it from the beginning. So we rewrote it, and I did all that. But then when we were taking the derivative, plus there was not enough room. I think that's part of it. I didn't even know what I was looking at. Not trying to make excuses. I just totally screwed up. But when we took the derivative of the inside here, 2x, and then this, and we did the chain rule, we should have just multiplied 5 by this part, not by the whole thing. Okay, so then it just throws everything off. So instead of just like fixing that, I just want to do it from scratch. Okay, so let's rewrite. We need to borrow a paper again because I don't even know what the question is. So g of x is equal to the square root of x squared plus the tangent of 5x minus 1. Okay, thank you. So go ahead and just rewrite that on the back there. So the first thing we do want to do is rewrite that square root as something to the 1/2 power, right? So I'll just say that this is equal to, then that's going to give me x squared plus the tangent of 5x minus 1 to the, see, I almost missed a parenthesis there too, to the 1/2 power. I'm running out of room. Okay, do you agree that that is the same thing? Okay, so we're going to take the derivative, right? I'm not going to write out the u's and the u primes, and if you still need to, that is totally fine. Just going to kind of recognize what it would be, because we're going to have to do the chain rule here a couple of times. So if I look at, this is what right now is on the, quote, inside, right? So I'm going to take the derivative of the outside, leave the inside alone. Make sense? Okay, so then I'm going to say that, so that's all g of x, g prime of x is equal to. So if I take the derivative of the outside, that'll give me 1/2. I leave the inside alone. X squared plus the tangent of 5x minus 1. Close my parentheses. What's my exponent? Negative 1/2 power. Okay, so I took the derivative of the outside. I left the inside alone, right? Now I need to take, then I'm going to multiply that by the derivative of the inside here. Am I missing somebody? Okay, who's this thing? Yes, thank you. Dun, dun, dun. All right, so we're going to take the derivative of this, and we're not going to do weird things, okay? You look at it term by term. We start with this term right here. That x squared, nothing fancy happens, right? It's just the power rule. So I'm multiplying it by the derivative of all that, so I do need parentheses here. So what's the derivative of x squared? 2x, okay? Then plus, now I'm going to take the derivative of this part right here. Is that going to require the chain rule? Yes, because I'm taking the tangent of something other than just x, right? So right now, this is like my u. So now when I'm getting to this term, the tangent term, I take the derivative of the quote outside, which is just the tangent part. And what's the derivative of tangent? Secant squared. So it's secant squared. I leave the inside alone, times 5x minus 1. Right? Anytime you're taking the derivative of the trig stuff, you leave that, the argument, this part right here is called the argument, that never changes. Okay? And so then, because it's the chain rule, I took the derivative of that part. Now I have to take the derivative of this inside part right here, and I multiply it just by this part here, and that's times that 5. Okay? My suggestion when you have multiple things you're doing in here is when you think you're done, go back and double check yourself and look and see what we did here. So we took the derivative of the outside, we left the inside alone. Check. Then we're going to take the derivative of this. So the derivative of x squared is 2x. Then I have to take the derivative of this part. So to do that, I need the chain rule again. Derivative of tangent is secant squared. I leave the argument alone. Then I have to take the derivative of this inside part, and that's that 5 right there. Okay? See where everything came from? Just remind yourself, derivative of the outside, leave the inside alone. So then, to clean this up a little bit, I have this is to the negative 1/2 power, which means that's going to go in my denominator, right? This 2, since it's 1/2, 2 also goes in the denominator, right? Since that's a negative 1/2, I can make it a square root. I can leave it as a 1/2 power. It's totally fine either way. But that's x squared plus the tangent of 5x minus 1. And then this, none of this was to the 1/2 power. So none of this was to a negative power. So all of this stuff goes in the numerator. So I will have 2x plus, I'm going to just put that 5 in front of the secant, just because it makes more sense, and that's kind of the proper way to write it. 5 times the secant squared of 5x minus 1. Everybody okay right now? If I lost you anywhere, if you know, is everything we do going to be this long and crazy? No. Okay, but are we going to see some that might look like this? Yes. Can I cancel these 2's out? No. Even if I could, would I have to? No, so don't. So you don't do something ridiculous like cancel those 2's out after you did all the hard calculus stuff. Ask me a question. Jaden, ask me a question. Yes, exactly. It's because when I take the derivative of that, if that stood alone, then I'm taking, to take the derivative of the tangent, it's this times the derivative of the inside. So that's why all that is together. Okay. Or what I did last time is I made it by the whole thing, and that was not correct. And I don't know what happened with my brain. But okay. We good with all that? Any questions? Sorry if I made things worse instead of better on that one. The good news is, at least I caught myself. I'm usually not that far off on things. Usually it's dumb things that I can't add and subtract. All right, so remember, if you haven't done so already, I want you to go and finish these, and I do have the answers to these in the key notebook so that you can check it, all right?